Good morning. Today we're going to continue on with our data structure course. We're looking at specifically the idea of creating a generic data structure. We're going to start off by doing that by using the idea of a node type. So we looked at originally the idea of an int node array based off of int node objects. And what we're going to do is we're going to actually generify that by using the node of class type. And so as you can see right here inside our lovely UML diagram, we have the same basic approach we're seeing with our int node. However, we're going to start off very basic with this. We have a node data of type, and then we have a node pointer, which is a node of type pointer. And then again, we have our same basic set of constructors where we have a default constructor, a constructor that takes a value, as well as a constructor that takes both a value and a pointer reference, and the standard set of accessors of get and set that go along with that. So we've got our basic design right here. As you can see, it's very similar to our int node object. We're just going for, instead of having only the capability of holding ints, this one can hold any type using the template class that we'll be using inside C++. So let's go ahead and actually take a look at the code that goes along with that. Here inside the template class, we're going to be actually using a little bit different structure. At the top of the file, we have our standard idea of the hashtag if and def and hashtag define, using what we've been doing for all of our class definition files. And we're adding this lovely prefix to the class. We're saying this class itself is a template class, a template of class type. And this information is going to be used to actually define how we can make a class that can hold any different kind of thing, regardless of type. And that's what we'll be using with this template. As you can see in our private data member section, we have the fact that we have a type data member. This matches right here the idea of type. We see it throughout the code right there. We also have, as a private data member, we have our node of type pointer called node pointer. And again, this is a reference to the actual class itself. And you'll see that basically every time we're talking about the class itself, we're going to use the idea of the angle bracket type, that gang sign we learned back in Java days, because every time we're making this kind of thing, we're actually making a node of that type, whether it be an int, a string, a car, a Pokemon, whatever. So that's where we're going to go from that. If we look at our public section, we have our constructor as well as our methods that go along with this. As you can see right here, I'm using the keyword type right here on my constructor. Now right here, this type on angle brackets is not required for the constructor. We're going to go ahead and actually take it out as we go through this. We can actually see this a little bit better. It'll more directly match what we put inside the implementation file, or implementation section, excuse me, of the file. And we'll go ahead and look at that. So we have our default constructor, which we're going to take a especially close look at. We have our constructor that takes a single data member, a single parameter of data of type, so we can actually assign into our data member of node data, as well as the standard 2-parameter constructor that takes the data member for type and a data member for, that takes a parameter for type and a parameter of node type pointer. And then we have our getters and setters that look just like we've been doing all year long inside Java and any other C++ program we've been looking at. Now, where this gets different, where this is special, we're dealing with the idea of a templated class. And again, because C++ is a special language, we have some different things we have to address with this. And so normally right here, you would see the class itself end after the semicolon. We have the hashtag indif right there. But because we're dealing with templates, because the class itself is recompiled every time we use the different type, we have to actually store the implementation and the class definition in the same file. So it changes our design structure we've been using for the year a little bit up. So we're going to take a look at that. So we're going to scroll down through the file. And as you can see, we have then every single thing defined all the way down to the bottom. As you can see right here, we have our implementation section. I have all the methods collapsed so we can actually see them all on the screen right now. If you notice though, as we look throughout the actual structure, every single method and constructor is prefixed with that template class type line. That line is going to go in front of every single method we do with all of our templated data types. Because what's happening is it actually has to specify that the constructor or method that's associated with this has actually a type attached to it. Because what we're doing is everything in here is attached to the type. And so we can actually use that keyword type inside our code and use it effectively. We have to have that template class type attached to all of that. So let's go ahead and we'll actually expand out our first constructor, the default constructor. As you can see, I have my node pointer is equal to null pointer because I'm initializing that default node. I'm pointing to nothing for my default value, but notice explicitly I'm not initializing node data. The reason I am not initializing node data is because I don't know what kind of thing it's going to be. It could be something that has 1 parameter, 2 parameters, 18 parameters. We have no idea. It could also be simple values simply as a 0 or a string with using quotes. And because we can't simply assign a string into an int or an int into a string or any other type across that, because C is a strongly typed language, I don't want to cause any problems with that. And so I'm explicitly, against regular standard code, not initializing my data member inside my constructor. And so that's just to keep things nice and safe and easy and not cause any cross-compilation errors. So explicitly in my default constructor, when I create just a node object of whatever type, I'm not going to initialize the node data member. We'll take a look at the more standard definition we'll be using. We're actually passing a single bit of data. In that case, right here, I have the constructor takes a data member, or excuse me, a parameter of type type in my data. And so I will then initialize my node data member with that data, that parameter right there. Again, as you can see, just like regular Java or C++ programming, my parameter is initialized into my data member. And then because, again, I don't know where I'm pointing to, I'll initialize my node pointer to be null pointer. Nice and easy. And then if I have a more explicit parameter or constructor, I have the constructor where I actually know what I'm dealing with and what I'm using. And so in that case, I have right here where I'm going to take the node data as the value that says a parameter, and then my next node will be initialized into my node pointer. If an actual idea of knowing which node I'm going to be pointing to because I'm at the current node, I can specify that right here with the value and its associated next node that I'm going to be pointing to. And so that's a way we can actually use this. And we'll be seeing this a lot when we look at extending this class for other data structures. Now, as I go through, and I'm going to expand out all of these, we can see that our getters, regardless of the thing that we're using, for the return is simply return node data, return node pointer, because it's simply just a regular getter. The only difference is that we have, again, that prefix of template class type. We have the return type is this type again. Now, as you can see right here, it has that underscore, underline, little dash line that surrounds it, going on all of that. That's the way that we know inside this that everything we're dealing with in here is of that type. And so whatever type this is, whether it's an int, a car, a monkey, a Pokemon, whatever we're dealing with, we know exactly what we're returning based on what we're actually passing in. And then because the class that we're dealing with is a parameterized type, node of type, that's going to be what we put inside the scope resolution class operator right there, followed by scope resolution, and then the name of the method and any parameter list that is attached to us. In the case of getNodeData, obviously there is a 0-size parameter list. We take a look at that right here on the setters, the template class type. Again, those are always of type void, standard return type right there, just like everything else. Again, we have the class name and then the angle bracket type that goes along with it because the object itself, the method we're dealing with, is of the node class. What kind of node class? A node of type class. We use the scope resolution operator just like everywhere. And then the parameter set of type data, and just like inside everything else, this selector node data equals data, just like every other setter we've written throughout the year. Again, that continues on a set node pointer. So as you can see structurally, the idea is that we have this template class type as a prefix to every method we're dealing. And then when we're dealing with a parameterized type, we have the node of type as the beginning of the scope resolution to say what class it belongs to. And that goes for every single method inside the class, as well as all the constructors right here, node of type, node of type. And so we have that node of type that goes for the constructors as well. Finally, again, reviewing, we have on our default constructor, the one with no parameters, that we only initialize the node pointer to be null pointer, and we do not initialize our node data because the fact that our node data, whatever type it is, we do not know before we're actually creating it. And with that default constructor, we have no idea what's going to be going inside that. So we do not want to try and initialize something and cause some problems later on, because you can't simply assign a 0 into a string or a string into an int. It doesn't work. So we have to make sure we prevent against that by explicitly not initializing node data on that default constructor. Again, we have our header file for that. We'll go ahead and expand that out. And in the actual class definition header, we have our private section. Looks just like every other private section. We have our data members right there. We have our constructors and our methods spelled out inside the actual public section. And the structure is pretty simple. Let's go ahead and take a little bit more look at this. So I'm going to go over here into my controller section. I'm going to go to my structure controller HPP. And because I'm adding that lovely header file, I have to do the #include on that so I can get access to it. And since I'm using a string, I'm going to use the string #include as well as I'm using namespace std. And what I've done is inside my constructor, my controller, I've made a node of type int called number node and a node of type string called word node and a lovely method called test node types in my private net section. So I have that right there, and we're going to go to the associated compilation file or implementation structure. Inside our constructor, we'll do the regular job of a constructor where we initialize those data members. And in this case, I'm saying word node is a node of type string, and then number node is a node of type int. And when we do this, we have the idea that right now we're getting those default values. There's nothing inside them. So using that default constructor right here. So what happens is that this node of type string is compiled right now. I have a node of type string compiled, and then I have a node of type int that's also compiled. So I have it compiled so it can run int operations as well as one that can run string operations. I could also make one for any other model type I wish to create. And I'll go ahead and pass this one. We'll pass it a quick sample value of C++. And this one will pass the magic number 42. So we have right now inside our structure controller, we've initialized our node of type string to be a string node. It's going to node of type string, and then our node of type int has a value of 42. And so we then have this lovely method right here called test node types, and we're going to use the get node data. Again, we're using the exact same method, get node data, here and here. But because word node is a node of type string, that is going to return a string value, versus the get node data of type number node is an int node. And we'll have that information right there. We'll change that right there. So here is a string node, here is an int node. We save that, and inside the start method, instead of calling the test int array like we did in our previous project, we're going to call this test node type. So again, we have in our start method, we're going to go ahead and test the node template class. We're going to call test noding, and we're going to finish our template testing. We'll go ahead and run this new code. Our build is successful, always a great sign. We take a look at this, and we're going to go ahead and test the node template. Here's a string node, and it has the get node data of C++. Our getter is successful. Here's the int node 42. The information passed is associated properly. And it finished testing. Great. Let's go ahead and erase what's inside that. I'm going to go ahead and remove that value right there, as well as remove the 42, so we can see what happens with that. Now, we've gone through, we removed that. Again, reminding ourselves we're only using the idea of the HPP for the include. Because I don't have the HPP right here of the node class, I have instead the structure controller.hpp because I'm using the chaining factor that HPP has the node HPP pound included inside it. So we'll go ahead and rerun this. And so here is a string node, nothing inside it, an empty string. And here is an int node. And I have this lovely negative 1,728,093,478. That's just simply the int value of whatever was happening to be stored at that location that we were creating. And so what we see by this is we can see why it's important to actually initialize a correct value, because if we don't, we get some random information that we may or may not know. And because of the fact that we don't know how to build the type when we actually specify our constructor, and again, I'm saying type very special because it is a type thing. It's that angle bracket, that gang sign we were talking about. We don't know what type this is when we first compile it. It uses whatever the default value is for that. And because we don't know what that's going to be when we write the constructor of node, there's no way we can initialize a good default value for every single thing that's going to go in there. And because that's the case, on our default constructor right here with no parameters, we don't want to try and initialize our node data to be anything. We'll let that be handled automatically by the actual type that's inside the actual structure. We're going to build a structure based on node. It's going to be like the int node array that we built was only going to be hold ints. However, we're going to make it so that this new node array that we're making can hold any type of thing, and that we can then build an array based on that. And we'll look at how we can actually make a more stronger, more generic structure that can hold all sorts of things using that same lesson we built in the int node array class. So we'll go ahead and continue on with that in our next lecture. Thanks, and have a great day.